Okay, here we are with an HL calculation question all about SHM. Let's go for it. Hopefully you've had time to look at the question. You're told the total energy is 16 joules, that's going to be important, and you're being asked what is the kinetic energy of the mass when its displacement is half of the amplitude. Okay, so for this, I think it's first worthwhile remembering that the total energy is given by half of k times x naught squared. Now, x naught is our amplitude, as mentioned before, and that's equal to 16 joules. And we're going to use this relationship later in order to see what happens with the kinetic energy. Now, in SHM, the total energy is the sum of the kinetic and the potential energies. And so therefore, what I can do, and I realize there's a lot on the screen here, is I can think about the potential energy. Okay, so we're going to work our way from left to right here. Firstly, our value of x is simply half of the maximum displacement. The potential energy is going to be half of k times x squared. Okay, and that is going to be half of k of x0 over 2 squared, which is, if you follow the working through, 1/4 of that total energy. In other words, the potential energy here is 4 joules. Okay, now the kinetic energy is simply the remainder. We have a total of 16, we've got potential energy, which is 4, and so therefore my kinetic energy is simply going to be the difference between those two, and that our answer is going to be 12 joules. Now you could have done this another way by calculating a half m v squared and using the equation for relating velocity and x. However, I find this way a bit more straightforward. Up to you, you'll get the same answer. There's multiple ways of answering these questions in physics, so you choose the way which you are comfortable with.